For Lesson 4's homework, translations off the coordinate plane, the first thing we need to do with all of our translation constructions is we need to take our compass and we need to measure the length of our vector. So I'll set my compass up with the point on M and the pen on N. So now I have my established distance. And now I need to go to every point on our polygon and need to make a circle that is that size. So what I'm going to do is I'm going to do my best here to change the colors up for all 5 points. This way, it should help us visualize things a little bit better. Each point has their own circle. And the thing to keep in mind is, since all of these have to be the same exact size, I'm going to get them all done and out of the way with now. Set this way, I don't have to keep remeasuring the size of that vector as the process goes on. After we do that, now we have to work individually 1 point at a time. And we're always going to start with the point of our compass on M, because that was the starting point of our vector. So what we need to do is measure the distance from the start of the vector to that original point. So in this case, from M to C. Then we're going to slide that distance over to N, and we're going to make an arc. And that point right there is going to become C, move my compass out of the way here, C prime. Okay, and then basically we're just going to be on a little bit of a repeat process here. So then I'll go to circle B, which was my black circle. So perfect. We measure the original distance from M to B. Then we slide it over to N, the second part of our vector, and we'll make our intersection point. And that right there is going to represent B prime. Next circle I did was A. That was my green circle. So I'll go across, stretch out my compass. Hopefully it reaches. So you can see here I just fall a little bit short. Not that big a deal. Let's see if I can shrink my picture here a little bit. So I'll group everything together. Shrink it just a little bit, and now we should be able to match up that end point of M with point A. There we go, that's better. So again, we're not going to make our circle, we're going to slide it across so that the intersection is on point N. We get our point, and there is going to be A prime. And again, just got to be patient with me. We're going to continue to go through this process. Our blue circle goes for point E. So we'll go back to the original. We'll measure it out. Slide over to point N. Make our intersection point. And there's going to be E prime. And then last but not least, we will do the circle that matches up with point D. So I'll shrink my compass a little bit here. We'll go through, I'll slide it across to N. And then we end up with our last intersection point for D prime. And then to finish everything off, we'll connect our polygon. So we will go from A to B. We'll go from B prime to C prime. C prime to D prime to E, and then across. I know it's hard to see through all the circles, but we do have our translated polygon, okay? For the second one, in the diagram below, triangle EFG is transformed to make triangle E prime, F prime, G prime. Draw a vector line for each of the set of corresponding points of the triangle. Use these lines to explain why a translation alone could not map them across. So we're going to take some time here and draw our vector lines to represent, oh, don't want that, to represent all of our moves from original point to prime point. And I'll put arrows to make it a little bit clear where the vector side is. So if we remember, vectors should be parallel and equidistant. And by looking at this picture, especially E to E prime and F to F prime, I can tell that those vectors are definitely not parallel. So, because vectors E prime and F prime are not parallel, this cannot only be a translation. Okay? So if you remember, our vectors got to be parallel and equidistant. We clearly don't have that here, so therefore not a translation alone.